Welcome to day 8 of our object-oriented programming course. Today we will dive into lists, an essential data structure in Python. We will cover everything from basic list operations to advanced techniques like list comprehension. Let's start with the basics. A list is an ordered collection of items in Python. Lists are flexible. They can contain elements of various data types like numbers, string, or even other lists. For example, you can create a list like this: my list equals to 1, 2, 3, Python. As you can see, this list contains both integers and a string. Now let's explore some common list methods that will help us manipulate lists efficiently. We can use methods like .append x to add an element to the end of a list, or .insert I, x to insert an element at a specific position. If we need to remove an item, .remove x will do that, and .pop I allows us to remove an item at a given index. Don't forget about .sort to arrange list items in order, and .reverse to reverse the order of elements. Slicing is another powerful feature in Python lists. You can extract a portion of a list using the slice syntax. List start stop step. For example, my list 1 4 gives us elements from index 1 to 3. You can also slice with a step like my list 2, which will return every second item from the list. Remember, slicing does not change the original list. It returns a new one. Next, let's talk about nested lists. A nested list is a list that contains other lists as elements. For example, nested list equals to containing the lists 1, 2, 3, 4, and 5, 6. You can access elements within nested lists by using multiple indices. For instance, nested list 0 gives us the first list 1, 2, and nested list 0, 1 gives us 2. When working with nested lists, you might need to iterate through both the outer and inner lists. You can use a nested loop for this. Here's an example. For each sublist in the nested list, loop through each item in that sublist and print the item. This allows you to access every element, no matter how deeply nested it is. Let's move on to list comprehension, a concise way to create lists based on existing iterables. The syntax is simple: expression for item in iterable if condition. For instance, x ** 2 for x in range 5 generates the squares of numbers from 0 to 4, producing 0, 1, 4, 9, and 16. List comprehension makes code more readable and efficient. You can also use list comprehension with conditions. For example, x for x in range 10 if x modulo 2 equals to 0 will generate a list of even numbers between 0 and 9. And you can even use list comprehension to create nested lists like x for x in range 3 for y in range 2, which creates 0, 1, 2 and 0, 1, 2. Now it's time for you to practice what we have learned today. Here are some exercises for you. Create a list and perform methods like append, remove, and sort, and also try slicing the list. Work with a nested list and iterate through it to sum all the numbers. Use list comprehension to find numbers divisible by 3 in a range and create a multiplication table. For your mini project, we will build a simple to-do list app. We will use lists to hold tasks and dictionaries to store additional details like the task name, due date, and status. Here's an example of a task stored in a dictionary. This will help you get comfortable with combining lists and dictionaries. To summarize, today we have learned that lists are an incredibly versatile data structure in Python. We explored various list methods, slicing techniques, and how to work with nested lists. We also saw how list comprehension can make our code more concise and readable. Make sure to practice these concepts as they are fundamental to Python programming. Welcome to day 9 of our course. Today we will be learning about tuples in Python. A tuple is an immutable, ordered collection of elements. Unlike lists, which are mutable, tuples are used when you want to store data that should not change after creation. Tuples are defined using parentheses as opposed to square brackets for lists. Let's start by creating tuples. A tuple can be created by placing elements inside parentheses. For example, my tuple equals to 1, 2, 3 creates a tuple with 3 elements. Tuples can also be empty or have a single element. An empty tuple is defined as empty tuple equals to only the parentheses. And a tuple with a single element looks like this. Single tuple element equals to 1, comma. The comma is necessary when there's only one element. You can access elements of a tuple using indexing, just like lists. Remember, indexing starts from 0. For instance, my tuple 0 will return 1. Negative indexing allows you to access elements from the end, like my tuple minus 1 will return 3. Tuples support several operations. For instance, you can concatenate two tuples using plus operator. If we have tuple 1 equals to 1, 2 and tuple 2 equals to 3, 4, concatenating them results in 1, 2, 3, 4. You can also repeat tuples using the asterisk operator. For example, 1, 3 asterisk 3 results in 1, 2, 1, 2, 1, 2, repeating the elements 3 times. One of the powerful features of tuples is tuple unpacking. You can unpack a tuple into individual variables. For instance, if you have coordinates equals to 4, 5, you can unpack it into x, y equals to coordinates. So x equals to 4 and y equals to 5. Tuples can also be nested, allowing for nested unpacking. For example, data equals to 1, 2, 3, 4 can be unpacked as a, b, c, d equals to data, resulting in a equals to 1, b equals to 2, c equals to 3, and d equals to 4. Tuples have a few built-in methods that can be quite useful. For example, count returns the number of times an element appears in the tuple. So for my tuple equals to 1, 2, 3, 1, 1, my tuple.count1 will return 3. Another method is index, which returns the index of the first occurrence of an element. For example, my tuple.index2 will return 1. One of the key characteristics of tuples is their immutability. Once a tuple is created, you cannot modify its elements. If you try to change an element like list, like my tuple 1 equals to 4, it will raise a type error. This immutability makes tuples efficient for storing fixed collections of data. Tuples are often used for returning multiple values from a function. For example, you can define a function get min-max values that returns both the minimum and maximum values as a tuple. Tuples are also useful when you need to assign multiple variables at once. You can do this with a single line a, b, c equals to 10, 20, 30. Now let's compare tuples to lists. Tuples are immutable, meaning their contents cannot be changed after creation. On the other hand, lists are mutable and can be modified. In terms of performance, tuples are generally faster than lists, especially when used for fixed collections of data. So use tuples when you want to store data that should not change and lists when you need to modify the data. One advanced use of tuples is that they can be used as dictionary keys. Since tuples are immutable, they are hashable, which allows them to be used as keys in dictionaries, unlike lists which cannot. For example, you can have a dictionary like myDict equals to 1, 2 colon value, where key is a tuple 1, 2. To help reinforce what we have learned today, here are a few practice exercises. Tuple unpacking exercise. Create a tuple of 3 elements and unpack them into separate variables. Dictionary with tuples as keys. Create a dictionary using tuples as keys. Function return tuple. Write a function that returns the largest and smallest values in a list. Practice immutability. Try modifying a tuple to understand the concept of immutability. That's all for today's lesson on tuples. We have covered their definition, creation, operations, methods, and how they differ from lists. Practice the exercises and experiment with tuples to gain a deeper understanding. See you in the next lesson. Welcome to day 10 of our Python course. Today we will explore dictionaries in Python. A dictionary is a collection of key value pairs where each key is unique and maps to a corresponding value. Dictionaries are unordered and mutable, meaning their contents can be changed after creation. They can also store mixed data types, making them versatile for various use cases. Let's start by creating a dictionary. The syntax looks like this. myDict equals to key1 colon value 1, key2 colon value 2, key3 colon value 3. Here's an example. We can create a dictionary called student to store information like the name, age, and codes. Student equals to name colon June, age colon 20, course colon computer science. To access values, you use the key inside square brackets like this. Student name, which would return John. Now let's see how we can modify or update dictionaries. For example, we can change the age of the student by assigning a new value. Student age equals to 21. We can also add new key value pairs. Here we add the graduation year. Student graduation underscore year equals to 2024. To remove an item, we can use del or pop. For instance, del student course will remove the course key. Next, let's look at how to iterate through a dictionary. You can look through just the keys using student.keys, through just the values with student.values, or through both the keys and values using student.items. For key comma value in student.items, print f key colon value. This will print each key along with its corresponding value. Python dictionaries come with several useful methods. For instance, clear removes all items from the dictionary. The copy method returns a shallow copy of the dictionary. If you want to safely access a key without causing an error, use get. If the key does not exist, it will return none. To get all the keys, values, or key value pairs, you can use keys, values, and items respectively. Dictionaries can also be nested, meaning you can have a dictionary inside another dictionary. Here's an example. Employee equals to name colon Alice, details colon age colon 30, department colon HR. To access nested values, you simply change the keys like this. Employee, details, age, which will return 30. Now let's put what we have learned into practice with a mini project, a to-do list app. We will use a dictionary to store tasks and where each task has a unique ID along with attributes like the task name, description, and status. Here's how we can define the structure. Task is assigned an empty dictionary. Def add task, task ID, name, description. Task, task ID equals to name colon name, description colon description, status colon pending. This function adds a new task to the dictionary. Let's continue with our to-do list app. We can add functionality to update a task status. This allows us to manage tasks dynamically, adding, updating, and removing as needed. For your assignment today, create a dictionary of employees in your company. Include their name, position, and department. Then implement a function to retrieve all employees from a specific department. You can also experiment with dictionary methods like get and items to interact with the employee data. Here's a sample structure for the employees dictionary. That wraps up our lesson on dictionaries. We have covered their creation, modification, iteration, and some useful methods. Don't forget to practice with the to-do list app and the assignment to solidify your understanding. See you in the next lesson. Welcome to day 11 of our Python course. Today, we will be exploring sets in Python. A set is an unordered collection of unique elements, meaning it does not allow duplicates. For example, my set contains the values 1, 2, 3, 4, and 5. Let's dive deeper into what makes sets so useful and how we can work with them. So, why should we use sets? First, sets automatically eliminate duplicate elements. Sets don't maintain any order, which makes them perfect for situations where you just need to check for unique values. For example, if you convert a list like 1, 2, 2, 3, 3, 4 to a list, the result will be 1, 2, 3, 4, removing all duplicates. This makes sets particularly handy when you are working with large amounts of data. Now let's look at some common set operations. The union operation, denoted by a pipe symbol, combines the elements of two sets. For example, if you have set A as 1, 2, 3 and set B as 3, 4, 5, the union will be 1, 2, 3, 4, 5. Next, the intersection operation, denoted by ampersand, finds common elements between two sets. Using the same sets, set A and set B will return 3 as 3 is the only common element. Moving on to more set operations, the difference operation, denoted by a minus sign, returns elements that are in one set but not the other. For example, set A minus set B will give 1, 2 because these are elements in set A that aren't in set B. The symmetric difference, denoted by, gives elements that are in either set but not in both. So set A, set B will return 1, 2, 4, 5, which are elements exclusive to each set. Sets have several useful methods. The add method lets you add elements to a set. For example, mySet.add6 adds 6 to the set. The remove method removes an element from a set. But be careful, if the element does not exist, it raises an error. For example, mySet.remove4 will remove the element 4 from the set. On to more set methods, the discard method is similar to remove, but it does not raise an error if the element is not found. For example, mySet.discard4 will remove 4 if it exists, but will do nothing if 4 isn't in the set. The pop method removes and returns a random element from the set. It's important to note that since sets are unordered, you can't predict which element will be popped. Finally, the clear method removes all elements from the set, effectively leaving an empty set. Sets also support set comprehension, a concise way to create sets. Just like list comprehension, you can use set comprehension to create a set from a sequence. For example, x asterisk asterisk 2 for x in range 6 will give 0, 1, 4, 9, 16, 25, which is a set of the squares of numbers from 0 to 5. Let's summarize what we have learned about sets today. Sets are unordered collections of unique elements, making them ideal for tasks like eliminating duplicates. We explored operations like union, intersection, difference, and symmetric difference. We also saw some set methods such as add, remove, discard, pop, and clear. Finally, we learned how to use set comprehension for more compact code. These tools will help you work efficiently with sets in Python. Welcome to day 12 of our Python course. In today's lesson, we will dive into the world of strings, converting strings, covering strings methods, formatting, and manipulating techniques to help you become proficient with handling text data in Python. Let's start by understanding what a string is. A string in Python is simply a sequence of characters enclosed in either single or double quotes. For example, hello or world. Strings are essential for working with text data, and they offer a wide variety of operations such as concatenation, slicing, and formatting. One common operation with strings is concatenation, which means combining two or more strings. In Python, you can concatenate strings using the plus sign. For example, let's say we have two strings, hello and world. By combining them with a space in between, we get hello world. It's that simple. Another important operation is string slicing. Slicing allows us to extract a portion of a string. We do this by specifying the start and end indices. For instance, if we have the string hello world and we want to extract hello, we can use slicing text 0:5. Here's a great way to grab specific parts of your strings. Now let's talk about string formatting. Python offers several ways to format strings. One way is using the format method. For example, if we have a variable name set to John, we can use the format method to insert it into a string hello.format name. This will output hello John. A more modern way is using f strings, which allows us to embed variables directly in the string like this f hello comma name. String interpolation is another powerful technique, particularly with f strings in Python. This allows you to embed expressions directly inside strings. For example, if you want to include the result of a calculation, you can write something like f the sum of a and b is a plus b. It's a convenient way to include dynamic content in your strings. Python strings come with many built-in methods. One useful method is upper, which converts all characters in a string to uppercase. For example, hello.upper would output hello with capital letters. Similarly, .lower converts all characters to lowercase. So hello.lower will give us result hello with all characters in lowercase letters. These methods are handy when normalizing strings. Another essential string method is strip, which removes any leading or trailing white space. For instance, if you have the string hello, using strip will result in hello. Also, replace is used to replace a string with another. For example, hello world.replace hello, Python will give you hello Python. Let's now look at the join method. This method is used to join a list of strings into a single string. Suppose you have a list like apple, banana, cherry. Using join with a space separator, dot join words would return apple, banana, cherry. It's a useful method for combining multiple strings into one. Python also offers several methods for testing and comparing strings. For example, starts with checks if a string begins with a specific substring, while ends with checks if it ends with one. For example, hello world starts with hello would return true. These methods are great for string validation. Similarly, find is a method that returns the index of the first occurrence of a string. If the substring is found, it returns -1. If the substring is not found, it returns -1. For example, hello world.find world will return 6 because world starts at index 6 in the string. Sometimes you need to include special characters in your strings, and that's where escape sequence comes in. For example, \n adds a new line, \t adds a tab, and / adds a backslash. So if you print hello \n world, it will appear as two lines, hello on the first and world on the second. Now it's your turn for a practice session. Your task is to write a Python program that converts a string to uppercase, replaces space with underscores, checks if the string starts with a vowel, and splits the string into words. This is a great way to test and reinforce your understanding of string operations. To summarize, today we have covered a range of string methods and operations including concatenation, slicing, formatting, interpolation, and common string methods like upper, lower, and replace. We also explored escape sequences and string testing. Keep practicing these concepts to build your confidence and skills with string manipulation in Python. Thank you for joining me today. Welcome to day 13 of our Python programming course. Today we will be diving into exception handling in Python. We will explore how exceptions work, how to manage them efficiently, and how to raise your own custom exceptions for better control over your programs. Let's start by understanding what exceptions are. Exceptions are errors that disrupt the normal flow of your program. They occur during the execution of your program, often causing it to crash if not handled properly. So, why should we handle exceptions? The main reason is to prevent your program from abruptly stopping. Instead, we can provide meaningful error messages to the user, improving the overall experience. In Python, we use the try, except, finally structure to handle exceptions. Here's how it works. The try block contains the code that might raise an error. The except block is where we catch and handle the exception if one occurs. The finally block runs no matter what, whether an exception occurred or not, allowing us to clean up resources or execute important final steps. Let's look at an example. In this code, we ask the user to enter two numbers and perform a division. If the user enters a non-numeric value, a value error will be raised. If the user tries to divide by 0, a zero division error will occur. Regardless of the error, the finally block will always print execution completed. This ensures that the program does not crash unexpectedly. Sometimes you might want to explicitly raise an exception in your program. You can do this by using the raise keyword followed by the exception type and an optional error message. In this example, we define a function to check if someone's age is under 18. If it is, we raise a value error, signaling that the age must be 18 or older. Here we call the check age function with an age of 16. Since 16 is less than 18, a value error is raised. We catch this exception in the except block and print a custom error message. Error: age must be 18 or older. Now let's talk about custom exceptions. In Python, you can create your own exception by subclassing the built-in exception class. In this example, we define a custom exception called negative number error, which is raised if a number less than 0 is processed. This gives us more control over how specific errors are handled. In this example, we attempt to process the number -5. Since negative numbers are not allowed, we raise the negative number error exception. This exception is caught in the except block, which we print where we print the error message: error, negative numbers are not allowed. Sometimes you need to catch multiple types of exceptions in one block. You can do this by specifying a tuple of exception types in the except clause. In this example, we handle both value error and zero division error in one block. If either exception occurs, we print the corresponding error message. Exceptions in Python follow a hierarchical structure. The base class for all exceptions is base exception, followed by exception and various specific exceptions like value error, division zero error, and file not found error. Understanding this hierarchy helps you know which exceptions can be caught and how to handle them appropriately. When an exception occurs, Python provides a traceback message, which is a detailed error report that helps you identify where the error happened in your code. Here we see that when we try to divide 10 by 0, Python raises a zero division error and provides a traceback to help you pinpoint the exact location of the error. Now it's your turn. For this exercise, write a program that prompts the user to enter a number. Your program should handle invalid input such as value error when the input is not a number. It should also handle zero division error when the user tries to divide by 0. Additionally, raise a custom exception if the input is 0, indicating that 0 is not allowed. To wrap up, remember that exception handling is crucial in ensuring your program runs smoothly even when errors occur. By using try, except, and finally blocks, we can catch and handle errors efficiently. Raising custom exceptions gives you even more control over how errors are managed. Lastly, always use Python's helpful tracebacks for debugging. Happy coding! Welcome to day 14 of our course. Today we are working on a mini project where we will create a to-do list app using lists and dictionaries in Python. By the end of this session, you will have built a functional command line application to manage daily tasks. In this mini project, our objective is to build a simple to-do list app. This app will allow users to manage their daily tasks by adding, viewing, editing, and deleting them. We will use Python's lists and dictionaries to store and manipulate the data. Let's take a closer look at the core features of our app. Our tasks will be stored in a list with each task represented as a dictionary. Each dictionary contains key information such as the task's description, status, due date, and priority level. Here's an example of how the data will be structured. Each task will have these four important attributes. The core features of our app include adding a new task, viewing existing tasks, and deleting tasks. The user will be able to enter task details, including the description, due date, and priority level. Once added, the user can view all tasks and even delete them by specifying the task number. In addition to adding and deleting tasks, the app will allow users to edit task details and mark tasks as completed. This functionality makes the app interactive as users can manage their tasks effectively, ensuring they stay on top of their priorities. Let's dive into the code structure. First, we will focus on the function for adding tasks. When the user enters task details, our add task function will append a dictionary containing the task information to the tasks list. This ensures that the task is stored for future reference. Now let's look at the functions for viewing and editing tasks. The view task function will display all the tasks in the list, showing their description, status, due date, and priority. For editing tasks, the edit task function will allow users to modify the task details as needed. The app runs inside a while true loop, providing users with a menu of options to interact with the app. They can add a new task, viewing existing tasks, delete tasks, edit them, or exit the program. This loop ensures continuous interaction with the user until they choose to exist. Once we have the basic app running, there are several optional enhancements we can add. For example, we can implement file handling to save and load tasks, allowing the app to persist even after it's closed. We could also add task sorting or even advanced features like searching for tasks or setting task deadlines. By building this app, you will have practiced working with Python's lists and dictionaries, which are essential data structures for many applications. You have also gained experience in building a command line app and implementing core features like adding, viewing, and editing data. In the next step, you can enhance the app or apply these skills to other Python projects.